Given this array, which has 3 rows and 7 columns, I'm going to find the standard deviation and standard error of each column, and then go on and find the standard deviation and standard error of each row, and then use one command to find the mean and standard deviation of each row. To answer these questions, I'll click on the return key, then go to my live editor, then click on code, and then enter the array as a matrix. So I'll call my matrix A is equals to open brackets, and then we put in those observations, the 10, 9, 8, 7, 6, 5, 4, semicolon to indicate that I'm going to the next row, 1, 1, 4, 7, 10, 13, and then 8, then semicolon to indicate I'm going to the next row, 2, 4, 6, 8, 10, 12, 7. So we are done. I can just run to see our matrix there. So this one, a 3 by 7 matrix. I click on the return key there. I now go on and find the standard deviation of each column. So for the standard deviation, I'll call it SDC. Standard deviation of each column is equals to, the command that we use is std, open parenthesis, A. So this one will calculate the standard deviation of each column. So I'll go on and run. And here we are having 7 columns. So we'll be having 7 values for the standard deviation. So these are the values for the first column, the second up to the 7th column, which is having a standard deviation of 2.0817. I now go on to calculate the standard error of each column. By definition, the standard error is obtained by dividing the standard deviation by the square root of the sample size. So in this case, we are having each column has 3 observations, so it's a 3 there for the sample size of each column. So I'll click on the return key, and now I'm calculating the standard error for each column. So I'll call it SEC is equals to, and we are saying is the standard deviation of each column, then divided by the square root, of which we are taking now the square root of the sample size of each column. In this case, we can just count them 1, 2, 3. But if we have a larger array, counting them one by one might be a bit difficult. So we can use the command height. It will count the number of observations in each column. So it will be divided by the square root of, then open parenthesis, height. Open parenthesis, we are saying the height of A. So the height of A will count the number of observations in each column, which is convenient when the array is very large. So I'll go on and run. And we have the standard error for the first column is 2.8480. And we are having 7 different values for each column. I will now go on and click the return key. I will now go on and find the standard deviation of each row. So for the standard deviation of a row, so it's SDR is equals to, the command is std, and then open parenthesis, A, and then comma. And the second digit after the comma specifies the weight, because we are having a W here. In this case, we are not having any weights, so I'll just call my weight 0, and then comma. And then to specify that we need the standard deviation of each row, then I specify a 2. And then I go on and run. And we have the standard deviation of each row. For the first row is 2.1602. For the second one, 4.5356. For the third one, 3.4157. So that's the standard deviation there for each row. Now to go on and calculate the standard error of each row, I'll click on the return key and I'll call my standard error of each row is equals to, and then use our formula which says that the standard error is the standard deviation divided by the square root of the sample size. So it will be SDR, our standard deviation for the rows, divided by the square root, then open parenthesis, the sample size. Now when we are looking at the sample size, we use the command width, open parenthesis, A. So this command with A counts the number of observations in each row, of which in this case we could just have counted them. They are just 7. But when you have a larger array, counting them one by one is not convenient. So I'll go on and run. And we have the standard error there. For the first row is 0.8165. For the second row, 1.7143. For the third row, it's 1.2910. I'll now go on and look at the last question, finding the mean and standard deviation of each row using one command. So I'll click on the return key there. Then the command that we use is open brackets, and then we have an S, then comma, then M is equals to, and then the command std, open parenthesis, A. And we want the standard deviation for each row. So we'd have to specify a 2, but we cannot specify a 2 the dimension here without specifying the weight. The weight, we are not having any weight, so it's a 0, then comma 2. And then we go on and run. And what it gives us there, the S is the standard deviation of each row, 2.1602, then 4.5356 and 3.4157. And for the mean for the first row is 7. The mean for the second row is 6.2857. The mean for the third row is 7.